In this section for O300, we're going to take a look at probability. Probability is a measure of how likely something is to occur. When we talk about probability, the lowest probability you could possibly have is 0. And the highest probability is 1. So we're going to be looking at decimals or percentages for our probability, also throwing in some fractions. While we're talking about that inequality, if something has a probability of 0, that means it's not happening. That would be like the probability of it raining elephants tomorrow. It's not going to happen. A probability of 1 means the thing is certain to happen. %100% chance that that event is going to happen. Now, when we talk about probability, we talk about the probability of equally likely outcomes. What that means when we say equally likely, it means 2 or more things that have the same chance of happening. So, let's give you a couple of examples. I'm going to go back to the raining elephants. So we could have the probability of raining elephants. And the probability that I go to Walmart and they're selling concrete donuts. In the bakery. Other things that are a little less silly that might be equally likely. Flipping a coin. And getting heads, or flipping a coin and getting tails. You have one possibility for heads, one possibility for tails, as long as we assume that it's a fair coin, meaning it hasn't been altered in any way. Those are equally likely events. One other common one occurs when you are rolling a die. And let's say we're getting a 2. Or getting a 6. Getting a 2 or getting a 6, assuming that the die is a fair die, it hasn't been altered in any way, a 2 and a 6 are equally likely to show up when you roll a die. A sample space. The sample space, when we talk about probability, is the total number of ways something can happen. So a few minutes ago, or a few seconds ago, I used the flipping a coin example. So if we are flipping a coin, the total number of things that could happen would be that I could flip heads or I could flip tails. I have two elements in my sample space. If I want to roll a die, my possibilities are 1, 2, 3, 4, 5, 6. So that would be the sample space for rolling a die. The event. The event is the thing we want to happen. We call it the outcome. So if we were flipping a coin, and we wanted heads. So heads landing up would be an event. Rolling a die. Maybe we want to roll a 4. That would be an event. There are two types of events. We can have compound events and simple events. A simple event is one thing happening. So rolling one die, drawing one coin. Those types of things are simple events. A compound event is more than one thing happening. So maybe we want to roll a die and draw a card. Or maybe we roll 2 dice and we want the probability of heads on one and tails on the other. That would be compound probability. Now we need to take a look at how we're going to do this. When we're calculating probability, of an event, we'll call it E. So we would say P of E equals. We're going to have a fraction. And in the numerator is going to be the ways our event can happen divided by the total weighs yeah, let's do that. Our sample space can happen. Another way to look at it might be ways to get our outcome. Divided by total outcomes. So let's go use it. You ask a friend to think of a number between 4 and 12, and both of those are included. What is the probability he will choose 8? So we need to do two things. Number one, we need to define our event. So let's let our event be choosing 8. Now let's look at our sample space. We want to think of a number between 4 and 12, so all of the possible guesses. So he guessed 4, 5, 6, 7, 8, 9, 10, 11, 12. Those are all of the possible guesses that the friend could make. So the probability of E, of this person choosing 8, well, there's only one option for choosing 8. Our sample space only has one 8 in it. But he could guess any of those numbers. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers in our sample space. So he could guess one number. That's the only way he could get it right out of a total of 9 options. That means our probability of choosing 8 is 1 over 9. Two says you roll a fair 6-sided die. Fair means it's unaltered. All faces are equally likely. What is the probability you roll a 1? So our event is going to be roll a 1. We need to get our sample space. Well, when I roll a die, I could roll a 1, a 2, a 3, a 4, a 5, or a 6. Those are all of the possibilities. Only one of those is what I want. So the probability of our event, the probability of rolling a 1, is one possibility out of 6 possible outcomes. Now we have a refrigerator that has 5 blue Powerades, 4 red, 3 orange. What is the probability you stick your hand in and choose a blue? So I'm going to define my event. My event is choosing a blue. I'm going to define my sample space. There's my refrigerator. And I have 5 blue. And I have 4 red. And 3 orange. I have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 elements in my sample space. That means when I stick my hand in there, there are 12 possible bottles I could pull out. Only 5 of them are the blue one that I want. So I have 5 chances out of 12 bottles to pull out the one that I want, the blue one. So the probability of choosing a blue one is 5 out of 12. One of the more common problems in probability involves decks of cards. In case you need a bit of a refresher, a standard deck is 52 cards. There are 4 suits, 13 cards in each. And 3 of those cards are face cards. The Jack, the Queen, and the King. The suits are diamonds, spades, hearts, and clubs. Mine look a little more like puppy feet, but that's okay. Diamonds are red, spades are black, hearts are red, clubs are black. So Magician showed a magic card trick where he picked one card from a standard deck, determined what the probability is the card will be a black queen. So here's our event. We want a black queen. So my sample space is 52 cards. Now I need to look at the ways I could get a black queen. Well, I could have a queen of spades. Looks more like a Christmas tree, but that's okay. And I could have a queen of clubs. There's the only 2 black queens in the deck. So the probability of our event of drawing a black queen, I've got 2 ways I could do that. But I also have 52 cards that I could draw instead. Now, one of the things you have to remember with probability is we always want to reduce the fractions. So I need to do 2 divided by 52. You are welcome to do this by hand or in your Desmos calculator. Either way, you should end up in 1 out of 26 for your final probability. A lot of people also like spinners. So we have a spinner divided into equal parts. In case you are seeing this in black and white on your copies, this is red, orange, blue, green, purple, and white. After the spinner is spun, the arrow points to one of the colors. Find the probability of spinning red or blue on the spinner. Okay, not so bad. I have one red part, and I have one blue. That's 2 parts. I could land on. And still be happy. Two parts I could land on and it would be considered a success. Well, now we need our total parts, our sample size, our sample space. Well, that's all of the colors I could land on. I could land on red, blue, orange, green, white, or purple. My probability of landing on red or blue is 2, because that's 2 sections out of 6 possible sections. If we reduce it to lowest terms, our final probability of landing on red or blue is 1 out of 3. This one's a little bit different. If you roll a die, what is the probability you roll a 9? Well, here's our sample space. When you roll a die, we could have a 1, a 2, 3, 4, 5, or 6. There's not a 9 in there. That means the probability of a 9 is 0. It's not going to happen. This last one says, if you roll a die, what is the probability of rolling an even number? I am going to steal the sample space from number 6. Our event would be an even number. So that means I want a 2, a 4, or a 6. Well, that's 3 ways to get what I want out of 6 total things that can happen. So our probability of rolling an even number is a half. That is it for basic probability. In the next part, we will take a look at the fundamental principle